quite a bit.
Yeah. So welcome, everybody. Thanks for coming out on Friday, which is now Halloween Friday. I'm Andrew Johnston. I'm the director of the program in historic preservation. And tonight we have the very great pleasure of having Andrea Giordano from the University of Padua here. This lecture is the Hanbury Lecture in Historic Preservation. We have these lectures each fall. This year it's co-sponsored with IATH, the Institute for Advanced Technology in the Humanities. A number of us in the room had the pleasure of meeting Andrea last spring when UVA and the University of Padua signed a cooperation agreement that was the medical school and the architecture school had great involvement in this, in setting up this cooperation. And this is one of the first events, I think, where we've been able to exercise this new relationship. So Andrea teaches at the University of Padua, where he is the coordinator of the Master of Science course in Building Engineering and Architecture. And he heads up two labs, the Lab of Drawing and Representation and the Lab of Information Modeling. His recent scholarship examines the use of current computerized media for research in the field of detection, representation, and communication of architectural heritage. So please join me in welcoming Andrea.
Thank you. Thank you. I am so glad to be here. And please, excuse me, my English is very, do you say, Italian English, okay. And I thank you, everybody. It's a very good occasion to stay here. It's a very beautiful campus. It's a very, for me, it's a very, I discovered all the plan of Jefferson and also the relationship between Jefferson and Palladio, but all the things that Jefferson interpreted about Palladio with a very strong personality, I think, and also with a very strong idea of architecture that is so new for that time. I'll introduce my research. My research field now, my formation, I am architect. I was involved, but I am still involved onto descriptive geometry. But now we are a very huge research group involved onto the digitalization of cultural heritage from an historical point of view, from a touristical point of view, but in my case also for the preservation and the management of preservation of that cultural heritage. You know that cultural heritage is our legacy, and we have to intervene on it. In Italy now is a very bureaucratic, all the passages that we have to intervene on it. But the other thing is the dissemination, the communication of all the thing about cultural heritage. And I underline that this is a project visualizing cities and architecture, is a project coming from visualizing cities, visualizing Venice. That is a project that we organized between Duke University, Padova, and UAV, that is the Institute of Architecture in Venice. This is the book that we produce as final output of this research. The method is a strong relation between history of architecture, communication, reconstruction, and digital visualization. There are three topics that we have to try to shift onto history of architecture. And there is this very important quotation of a phrase of Manfredo Tafuri, how to switch from a static to a dynamic representation of cultural heritage, in this case for the architecture. We are involved in other projects. This is visualizing Carpi. Carpi is a very beautiful Renaissance, medieval and Renaissance city in near Bologna in Italy, where we were involved in 3 exhibitions about the city, about the cathedral, and about the transformation of the city. The other one is visualizing Padua churches, and this is especially coordinated by Caroline Bruzelis from Duke, about a church in Naples, very interesting for all the transformation during time. And another step in this research was to revisualize what is not existing anymore, but never realized. This is the project of Iapelli, one of the most important architects in Padua. New project is this one, A Portrait of Venice, is the interpretation from a digital point of view of the Jacopo de Barbari map of Venice. And this one is about the Hugi map. I will show you later the app that we created for this map. And the new one is this very interesting project that is Padova Invisible. It's about the visualization of all the hidden archaeological pieces, archaeological architecture, archaeological infrastructure onto the city of Padua. What is visualizing cities? This is the 5 points that we want to underline. We have to be collaborative and interdisciplinary, because we are not only architects, we are historians, we are informatics, we have people involved on social matters and so on. We use visualization because this is the new way to communicate this kind of problems. We depend on ICT, information communication technologies. We have to be open-ended because, as you know, the architecture, the city, the urban reality, the landscape is an organism, and then is on life, then is transforming during time. And for this reason, our research have a conceptual focus onto space and the dynamic of transformation. The methodology that we afford, and then also today we spoke about this, is so simple because we have primary and also secondary sources, elaboration, and output. Then 3 steps that we have to afford to obtain our results. We can start from primary sources, and as you know, all the primary sources are all the maps, cartographies, ancient photos, pictures, and cadastral maps that we can obtain for a precise reality. In this case, we have some image from Venice, for example. And all this kind of documentation are data where we can refer to justify all that we are representing. The thing that we have to do is this. We have to organize all these primary sources, all the documentation, archival documentation, to a database that have to be organized with a timeline. This is so important because all this kind of organization can be rational for our kind of research. The other one are the secondary sources, and this is not secondary because are not less important than before, but because there is our intervention, because are all the operation about laser scanning, survey of photogrammetry, and so on. This kind of output is very important because it's the actual condition of the heritage that we are surveying and that we want to analyze. The other step is the GIS, because we have to refer all the sources that we got, the data that we got, to the actual condition of the georeferencing. In this case, a map have to be georeferenced to this kind of system, and using some software, we can obtain a raw 3D model of this. This is, for example, ArcGIS. In this way, we can obtain, this is the insula of Accademia in Venice. And we can obtain the consistency of the volumes of the architecture in a precise time. But if we have some other information, we can reconstruct the real condition, for example, of domes, of the sloping of the roof, and so on, the windows, the doors, and so on. And the other step is about scan-to-beam. Scan-to-beam is so important now because we can start from a point cloud obtained by photogrammetry or laser scanning and going to a BIM, to a building information modeling that is an ideal model of that reality where you can charge all the information, but we can go again onto this. What I want to underline now is that the scan-to-beam is so important for the visualization of architectural heritage, for the analysis of the historical transformation, because you can layerize all the transformation onto this kind of model. But with this kind of model, you can also manage the project and the intervention onto that kind of building. And then can be the system that with who we can manage the heritage. And so, we can also organize all the yard phases for the intervention onto the cultural heritage, managing also the production process, because we need a precise, for example, if you have to substitute a brick, we have to reproduce that brick. And you know that the anastylosis is a very critical intervention onto the heritage, because you have to underline, not copying only the reality. And then for this reason, scan-to-beam can become an architectural heritage asset management. Is very good for our kind of intervention. Now, coming back to all the elaboration of the data, this is my field. And then, for example, if we have picture, as you know, a picture is a photograph and then is ruled by a perspective. That is a geometrical and mathematical method that you can use to obtain the real condition of what is represented. And the same if you use a picture of a precise period. In Italy, there is the Renaissance where we used the perspective, and in this case, you can obtain so much information about the history of the building that you are analyzing. This is the case of the church in Accademia Insula, where you can rebuild the tower, the bell tower that is not existing anymore. As you know, perspective is so important because you have to, for this reason, is a mathematical method, and then you can recognize the position of the observer, and then you can, using some, this is manual operation that you can obtain the real condition of what is represented onto that kind of picture. In this case, for example, for the San Giovanni in Paolo Campo, you can reconstruct the real condition of the Campo also from a dimension point of view, and also making some critical observation. As you know, Canaletto, that was a picture from Canaletto. Canaletto, somebody say that used a camera obscura, that is such a camera ante litteram. But in this case, there was not a use of camera obscura because the position of the observer is behind the buildings. Then he was not able to use the camera obscura. And this is also another step because you can recognize that, for example, Canaletto used a camera oscura for single pieces. And in this way, you can see that you have more than one observer that you can recognize onto this kind of representation. And then you can obtain the real position of the observer with three kind of dynamic representation of that campo. And also in this case, we use a method to orient, or a digital method that we can use using for not only the beam, but also a related software that we can use with BIM, that is a VPL method, a visual programming language, where you can use a script to obtain the real position from a picture of the observer, and then obtain all the restitution of the architecture, of the space that is inside that picture or that photograph. This is the case, for example, of an operation that we did also for this kind of research. That is, for example, we had some picture of churches destroyed during the Second War, and then we projected the condition of that destruction directly onto the BIM models using this kind of script. In this case, we obtain something like this, a script that we can, where we can recognize on these two pictures, they are so small, and you can see this is the destroyed roof of the church, and that is the facade destroyed of the same church. And in this way, you can project directly from the point of view onto the VPL all the condition of the architecture directly onto the 3D model. In this case, also inside, this is a picture inside, this is the position of the observer. You can project the, how do you say, the scissor, the lesione, the creep of the destroyed wall directly onto the wall of the 3D model. In this way, you can obtain the condition of the situation of the onto the cloud point and also onto the 3D model that we construct onto BIM. Visualizing Venice can be involving the BIM. We can analyze more than topics onto this kind of elaboration. For example, we can be interested in humanities, in religion, in city administration, also in everyday life. You can organize the model also in this case. And also you can have thematic examples as the evolution of the urbanization, myths, religions, and so on, the war, how the war destroyed the city. We are now in relation with Cologne, with Colonia in Germany. We are trying to reconstruct the condition of Cologne during the destruction. And also in this case, the very important data is that we have to link time and space. That now we speak about 5D 3D model, not anymore 3D model, but 4D model or 5D model, and now we are also arriving to 6D model. But anyway, the use of the data, the collection of data, is so useful also to organize the visualization from a layer point of view. For example, this is the insula of San Giovanni e Paolo in Venice. You want to read only the channels, or do you want to read the consistency of the buildings? And then you can overlap all this information onto a model and visualize only one, step by step, only one topic of that kind of visualization. And also the consistency of the transformation during time, and in this way you can obtain a transformation like this, coming back during time. We can obtain prototype, interactive models, and image and videos. And in this way, but this is the most important step, especially using BIM, is we have to create for cultural heritage specific families of objects that we have to charge of this kind of models, but we will see in the next PowerPoint. And this is the model of the destruction of the church during war, obtained by that kind of script of projection of a picture directly onto the 3D model. And we can obtain overlapping interactive slider onto between maps, between actual situation. We can use augmented reality. This is the case of the bridge onto the city of Padua, now hidden by the street. we can also have some picture that we can reference it to the actual situation. For example, this picture that is so old that we can overlap to the reality. Or the same for the painter, we can obtain the overlapping of Canaletto painting onto the actual situation. Then you can have a standpoint onto the city, and with your app you can obtain the visualization. Future step, you know that we have all the city that we can involve onto this kind of project, but we have to organize a very strong social network that can be involved onto this kind of project. And we have the integration between system and compliancy of standard, archival standard and computer standard. Then it's so important to be together using also the Dublin core that is so important for this kind of cultural heritage. And I don't see this. For example, you can rent for touristic finality a tablet, and then you can understand your hotel where is in relation to other heritage and so on. Then research, knowledge, and dissemination, but this is one of the first operative steps that I want to show you. We have the point cloud. Doesn't matter is in laser scanner or photogrammetry. They are so different, but they are useful both, and especially from more than one point of view, but I will explain this later. And this is so important. Just a moment. Sorry. This is the new building, the use of BIM for new building, and then you can obtain an as-planned BIM. That means how you want communicate the condition of the clone of the reality that you won't realize. But in the case of existing building, you have to put in relation the point cloud with the BIM, obtaining this name as built BIM. That means something that is related at the actual condition of that building. What is building information modeling? You know that I was in my university when I was young, I only drew. And then there was AutoCAD, and now there is the BIM. That is, there is this word that is joined with the building modeling. That is the information. And this situation is so important because there are two phrases that we can underline. This is the ISO standard national BIM phrase that we can use, a shared digital representation of built object, of any built object, reliable basis for decision. And this is so important, and also during its life cycle. And now in Italy and also in Europe is obligatory to use the BIM for a project that have a high level of expenses of money. And also the creation and use of coordinated, internally consistent, computable information. This is so important for this case of definition. But what is HBIM, Historical Build Information Modeling? Is the relation between something that is connectable with the present phrases, but is important to put together, in this case, the laser scanning and the creation of the family. What does it mean? As you know, with the new buildings, you can use families that are produced by industries, but the production of single elements that you are using onto the new project. In the case of existing building, historical building, you have to create this kind of object that you have to put on this kind of model. In this case, for example, for this monophora, you have to not only models the shape of the monophora, but also to put in relation each component of this kind of monophora. For example, the glasses, how do you say cornice, the profile, and so on. And also the beam for the historical building is important because you can organize all the structural information onto this kind of 3D model. In this case, for example, this is the Church of the Eremitani in Padua. You can organize all the points that are so important from a structural point of view to understand the behavior of this kind of building. And also the other thing is that you can overlap onto this kind of model all the phases about the church, about the transformation of the church, and in general about cultural heritage. This is a very important test that put in relation the point cloud with the beam model, because this is another thing. We can use the cloud point as the actual situation of the shape and measure of the architecture, but put in relation this kind of model that is an exterior model with a beam model, we can obtain so much information also about the difference between the reality and between the ideality of the beam model. In this case, for example, we use Red Scan2Beam as a free and open access Scan2Beam model that can allow us to put in relation each elements that we create onto the points, put in relation with walls, plans, and topography. And then we can obtain the clash geometry of the point cloud. We can also put inside all the MEP elements of the building, and also analyze the deviation of the walls, for example. In fact, if you overlap the building, the 3D model of the building with the cloud point, you can read directly which is the difference between the ideal verticality of the building and the deviation of the real wall that we are analyzing. This is so important for all the intervention about protection, about restoration, and so on. And this is an example. For example, overlapping the two models, you can put a parameter that where you can read the deviance of the verticality with a color. In this case, for example, the pink color represents the not verticality, not real verticality of that wall. For this reason, the beam realization is a very realization because we are creating a clone of the reality that overlap all these steps that we are involved to use before. Then we can start from primary sources. We can obtain a system of objects. Then we have to create the data that we have to put onto this kind of model. And then we can obtain the rough model that is approximate. Then we can overlap the operation of survey, this is laser scanning or photogrammetry, and then we can analyze all the surfaces and objects that we have to put onto the model from the laser scanning, and then we can obtain a customized object that is approximate. We are going to the semantization, what you will read. Then there is the model correction. We can start from the model, and then we can finish the model based on the cloud point, obtaining the as-built model. And this is all the thing that we have where we can put structural elements, local info, and material characteristics. And then, in this case, the model became a clone of the reality. And this is a very analytical model. And for this reason, the beam can be a simulation of the reality. And then you can put inside the sensoristic, because if you have a cultural heritage that you have to manage, if you put inside some sensors, you can read, for example, the movement of the walls during time, during a seismic or during some phenomena that can happen onto it. You can use the beam also for augmented reality, and you can integrate everything with structural, energetic, and conservation condition. In this case, you can charge more than one information, not only a shape, but all information that we can use onto the customizing of the model. I'm finishing with this. Now, I want to show you a precise research project I showed you yesterday. That is MONADY, Methodologies and Best Practice for Non-Destructive Approaches to the Interoperable Design and Management of Cultural Heritage. You know, interoperable is a very important word now, because the interoperability means that onto this kind of model can work all together more than one personality. Then can work on it not only the architect or the engineer or the structuralist or the restoration personality and so on. This project was with Singapore and Nanyang Technological University and Duke University, and it was about a church, and especially a room of this church in Padova. Is that one you can see is the Scuola del Carmine, that is a room near this church. This is the city of Padova. We have a lot of churches that we analyzed, and I will show you later a video about the other churches. But it's so interesting this because this is a very step ahead that we did. This is the context. This is the room. It's a very a simple Renaissance room where there is a very interesting collection of frescoes onto the walls. This is the church. This is the courtyard. Now, this is the three topics that we want to underline: the maintenance and control of structure through database and physical analysis, cultural enjoyment and building and frescoes through VR and AR and website, and cultural heritage valorization. There are three topics that we want to underline. We start with the 3D survey, then the Scoletta was acquired with a photogrammetry, and the same with the laser scanner, and also with a survey about centered onto the thermography of the walls, and also the georadar to understand the underneath of the room. I click here. This is the cloud point of the inside. You can see all the frescoes inside. This is the cloud point, and this is the survey of the square near the Scoletta. This is each orthographic wall from the survey, photogrammetry orthophoto. And you can see each scene. They are so interesting because they are from Renaissance, then they are in perspective, and they are related not only with the architecture of the place, but also with the landscape of the place, and so on. And this is, all the operation about thermography, and in this way you can obtain information about the condition of the wall, and also the operation of georadar to understand the condition of underneath, where we discovered that there is a street inside, the Roma street inside underneath the Scoletta. Then beam modeling. We studied this one, and we did an operation. We made an operation of scan to beam, starting from the point cloud, and then from this obtained the beam model. And the beam model is important in this case, and I will show you soon, because each element is a single family, a single object that we have to charge on this kind of model. And you can see here another problem that we have to underline onto this kind of operation, because when you afford a beam model, you can also take in account the level of details and the level of development that you have to decide for each element that you are representing. In this case, the same column, you can have a simple representation, the other one is more specified, and both can be charged with other information, for example, about the kind of material that is inside this kind of column and so on. The same for this kind of decoration. In this case, the construction of this 3D model is so difficult, but you can obtain all the parametric information also in the database that is inside the BIM, where you can also write, for example, when it was realized and when it was transformed and so on. Then you can put onto this kind of BIM model also all the information during time of the transformation of the heritage. Then another step that we afforded onto this project was the study of the frescoes. And in this case, we started with studying all the content of the biblical content onto each fresco. The frame was between two columns onto the walls, and each frescoes, you can see each one, but I can go faster here. Then we can organize all the information to obtain the augmented reality. Then each fresco, we have information about author, about religion, about landscape, about characters, about geometry. And that is so important because using geometry and using perspective restitution, you can obtain the 3D model, the virtual 3D model of a perspective that is an antiliteram virtual reality on the wall. And as you can see, you can reconstruct, using perspective, the real condition of the space that is behind the wall, and also overlapping the single personality that is inside onto the 3D model. And this is due to the same procedure that I showed you before, the recognizing of the position of the observer, and also the possibility to reconstruct the 3D model of the reality represented onto the wall. In this case, it's so slow. You can see the position of the observer, all the vanishing point that you can use to obtain the restitution of the shape of the room restituted onto the fundamental of the fresco. And in this way, you can also understand which is the position of the observer, the real condition that this point you can recognize correctly the representation of the fresco. And this is all the 3D model of it. This is one video. And then you can recognize the position of the observer. And from this, you can reconstruct the 3D model and enter inside the 3D model. And also recognize which is the position of the observer. From this, we are going to VR AR. In this case, we used the cloud point, the simplified cloud point that we have to bake. In this way, you can obtain a cloud point that can become a mesh. And in this way, you can use it also overlapping the image of single fresco. And then you can, you can obtain the single model, the simplified model that using in Unity, you can then manage onto virtual reality with Oculus Rift or a Cave or a Web VR. The case of Oculus Rift, for example, this is the outside of the church. This is the person that is the same experiment that we did today with the classroom of Andrew. You can enter the atrio, you can enter onto the room, and you can see all the information about each fresco and so on. Also in this case, you can see on the screen the same. The other one was about the cave, the immersive cave. It's so important also this because you can enter directly onto the space and move inside. In this case, we used the cave at Duke University, and in this case, we can enter onto the architecture, we can have some tags where we can obtain information for each fresco, for each wall, for each architectural elements inside the representation, the data, all the data that we need. In this case, you enter inside a space. No, it's more comfortable because you need only some glasses that can put together all the projection to 4 walls and onto the ceiling. I can go faster here. This is the organization of the visualization of the app for each fresco that we analyzed. And the thing that I want to underline now is the cultural heritage management. That is so important because in this case, coming back onto the BIM, for the use of the BIM from the asset, the point of view of the asset and management of the asset. We can, for example, understand the fresco awareness, the interior comfort, the fresco's preservation, how we can analyze the illuminance, we can control the humidity, we can management the HVAC, we access control too, because this is so important, because onto the cultural heritage, especially with fresco, it's so important how many people enter onto that room. And for this reason, all the BIM authoring software, we can use IFC for real-time data, and in this case for sensoristic and so on, and 3D solid format, then simulation, that is open source now, where you can charge all the other information. Then, existing historical building, we can find missing elements, in the existing one, real elements modeling, and in that we are sure of the information that we have to charge on it. For example, the geometry, that is the shape, the materials, and the connection that we have of each element that we are analyzing. And in this case, we have 3 parameters that are involved onto this kind of simulation, and thanks to this, we can verify and validate all the results. Let's see. We have, as I said before, we have different levels of details. This is a meticulous modeling, as I said before. This is a simple geometry. This is an historical reconstruction, and this is only a meshing of the situation of the piece that I want to analyze. Or I have some indoor simulation. We can understand which is the condition from a thermical point of view. We use the Vento software, I said you before, and we can analyze the condition of the heat of the coal onto each wall, not only interior but also exterior, and also all this can be analyzed from, how do you say, a fluid flow during time and during season. In this way, in this case, for example, you can know which is the fluxus of the heat onto this wall in a precise period, and then you can understand also on the other wall the precise condition. And for example, you can see that in January there is this condition of heat onto this wall, and during the summer we have this kind of condition. And then all this is very important to intervene onto this kind of wall, because there are some damage due to the sun that is going onto the wall. The same for this. And I don't know if you can see here the position of the building. In BIM, you can relate to the condition of the position of the sun during time. at least, as last, we are trying to produce a MIM, a museum information modeling, because it's a place where you can obtain information that can be perceived from each kind of visitors, but you have to put something in relation also of your preparation. And in this case, for the management, for example, you can use some part of this kind of topics that are underlined here. I want to show you where is it? The final video. If you want to dance. This is the Padova, Chiesa del Carmine. The red one is the Scoletta. All the data that we can obtain, we can georeferentiate everything, also with the cloud point, digital survey, that is the laser scan, but there is also the photogrammetry inside. From this, we can obtain the cloud point also inside with photogrammetry. The georadar and the thermography. Now, there are data that we can collect onto this kind of historical building information modeling, where you can read and understand all the phases of the history. The transformation is so simple, but also you can put inside all the technical meanings that you want to read. For example, the structure or the thermographical assets for each wall. And also for all the dynamic from outside to inside from a fluid point of view. As I showed you before, this is the condition of that wall. And the other one during time. And this is the other step. This is more touristic because you can read the virtual reality of that painting from a precise point of view, and the same for the old painting. And finally, there is the creation of the app, the virtual reality. The use of Unity in web VR, and the app. QR code, this is now, how do you say, so usual. And all the information that you can obtain from your mobile. I want to show you now another two steps of the research. I want to show you this video that is about Padova, but is the reconstruction of Padova from this map, that is a map of 60 here, century, sorry. And from this, you can obtain all the information of the building condition of that period, starting from the channels that we have. And this became an interactive map where you can obtain all the information about medieval fortified wall all around the city. This is the medieval part, and also the Renaissance part of the walls. Let's come to Padova again. and also all the ways of water now covered, not existing anymore. And now each single church still existing. This is the Eremitaani Church. And so on. I can go just a little bit faster, because the most important thing now is this. After all this, other church, they are church not existing anymore. As you can see, it's a very religious city, still now. And this is the building condition at that period. Now, this is the condition in that period, and with another project, we are now analyzing all the condition of archaeological situation. And for example, I'll show you this other video. PD Invisible is the new project that we are finished now with Colonia University. You can't dance now. I'm sorry. Only this part is visible in Padova about archaeology. This is the arena. This is Porta Altinate, where there is a bridge. This is San Lorenzo Bridge that is underneath. And then in Prato della Valle, that is a very huge square, you can find a place where there is a theater under the water. This is the arena, Bridge Altinate, Bridge San Lorenzo, and Prato della Valle with the Zairo Theater. The workflow is so simple, as I said before: data acquisition, data processing, and the beam modeling and data integration for each one. For augmented reality, data acquisition with the laser scanning, data processing of point cloud. This is a bridge. The beam modeling, as you know, as I said before, you have to simplify everything, but you can charge on it information from a structural point of view and from a material point of view. And overlapping with the cloud point, you can obtain so much more information. You have also all drawings about the old condition. This is all the photos of pictures. And virtual reality. Finish. Thank you. But I have to show you another video. Just a moment. I'm annoying you. Sorry. The last one is this. And you can dance again. This is about other two churches in Padua. I show you during our meeting in Padua. And this is about Santa Giustina Church in Prato della Valle and the Church of Servi. Also in this case, there was the collaboration, as I said before, with Duke University and Singapore University, Servi e Santa Giustina. The project is two cult, cultural tourism. We start from analysis of historical documents. The methodology is the same. The map that I showed you before, that you have to georeferentiate, and then you can start with a digital survey, the topography, the laser scanning inside the church, the photogrammetry. All this data can be put in relation with the 3D model that is an historical video information modeling, where you can charge information about the consistency of the architecture. For example, materials, decorations, structures, and so on. And also, in a timeline, all the information about the transformation of the building. The actual situation. And then you can also survey each decorative elements that you have to charge onto this kind of model. And also in this case, there is the Renaissance painting. And also in this case, we can repropose the virtual reality, entering onto it. The website, where you can interrogate each tag and each signal that you can obtain onto the model, and then the augmented reality for the transformation of the church, also here, and also if you want to represent all the project about the facade of the church, never realized. Here we go. Thank you. Have you got some question? Lights up is
Thank you very much. It's really beautiful stuff. Oh, yeah. I'm speaking here, so a disembodied voice. Thank you very much. It was really nice. The BIM model, getting down to kind of construction elements. There's still, especially the cultural heritage, there are structural elements that we won't have any kind of access to. That is, say, what actually is the structure inside, say, one of the bridge components or something.
For each church, you mean?
Right.
Yeah.
Yeah. So what kind of methods do you propose for trying to ameliorate that problem?
Yeah, we have some software that are involved on each kind of structure. For example, if you are analyzing a structure, a steel structure, you can use, I can say, Tekla or Midas for concrete. And for masonry, you can use Revit easily. And there are some links with a script that can recognize the behavior of walls, of roofs, and so on. And then you can charge all the information onto the 3D model in this way. The collaboration with people, engineer, is important because they can give you also other information with other software about the behavior during seismic happening and so on.
On some of the historical ones, you might not actually know what the material actually would be inside.
Yeah. There is some of these. There are you can do analysis as you say in English, carotaggio. That is a sonda, a sensor that you can put inside the wall, and you can understand the consistency of the wall. logically can be different during time, but you have information because there is a lot of documentation. And also all the documents that are only right are so important. And this is so important, the collaboration with historical personality, because they can recognize also from documentation about the construction, the material that they use, the real condition of the each element that we are remodeling. It's not easy, eh?
Additional question?
Just, I can see where the modeling at the scale of the building. I can see where the modeling at the scale of the building can go in all of these outputs and all. I'm really interested, though, in also the modeling at the urban scale, and I'm curious how you are planning to apply that knowledge that you've been able to get by, for instance, translating the maps. Is it to something I've always been fascinated with is that so much of the documentation and also the tourism is based on objects and artifacts rather than actually the spatial structure of the city or the organization of the city. Would this be ways of not just focusing on making the artifacts visible, but actually making the structures of the city visible? Is that where that's going for the future?
I have not heard the video about this, but we are in visualizing Venice and now in visualizing cities. We are interested in this. We are visualizing the transformation during time of whole the city. Then you can focus, if you are interested in a precise place, you can focus on that. But we are interested in all the city. And this is only, we can make this only with the documentation, because we have to justify everything. When there are more than one information, you can show both, but you have to justify each one with. There is this. I want to show you this. Visualize it. In this case, look, this is the case of Carpi, the visualization of the transformation of Carpi. We have a 3D model that is layerized. Then you can choose moving onto the timeline. For example, you can go in this period. You can have all the information from and read it from a plan point of view and a visual, a 3D point of view. And in this case, you can underline where there is the transformation with a different color. And this is all the transformation. And also, if there is a documentation, you can put in relation this. For example, there is a tag here, and then you can read the map of this thing, and then you are justified. There is a legacy that you can obtain about this. And let me see if there is the other one. No, it's not here. I'll show you. During the exhibition, for example, this is Carpi again. There were two projections, one on the roof about the plan of the city, and the other one in 3D that you have on the wall. And also there was the virtual reality, then you can put in relation both.
Other questions? May I have that? Thank you. If you would, this idea of museum information modeling, could you tell us just a little more about this? I'm interested particularly if this is something that can be for archiving data and making it publicly available.
Yeah. This is not our idea because it's still existing, but we are developing because in Italy, there are a lot of cultural heritage, and sometimes it's not disseminated. And for this reason, a model that is interoperable and concentrated to a museum is so important. We are now starting with a project with the Correr Museum in Venice about all the heritage that is inside, but we have to try to geolocalize each masterpiece inside onto the city virtually, logically. And this is very interesting. We hope that this project can go, I think it can be something that we can do together.
Okay, so if no more questions, let's again thank Andrea.